Hello class. Today we're on Chapter 1, Lesson 3, Multiplication. Learning the multiplication table is not an easy task. When you first learned how to multiply, you did it by adding. For example, the problem 3 times 5 can be illustrated by 3 sets of circles with 5 circles in each set. So here we have 3 different sets, 5 circles in each one. The circles can also be arranged in 3 rows to form a rectangle. And here we have, if you look across, 5 circles, and going down we have 3 sets. And both patterns show that 3 times 5 is equal to 5 plus 5 plus 5, which is equal to 15. In learning multiplication table, you memorize the answers to problems such as this so that pictures and adding became unnecessary. So one of the things that's going to be important in algebra is to remember your multiplication table. If you're not very strong with it, you're going to need to always reference the factors on the multiplication table. So if you're not very strong with it, you may want to brush up a little bit on it. Memorization is really, again, what we did with the multiplication table. But you're going to need to recall these numbers, see factors within, and we'll discuss that a little further down. Though in algebra, we sort of shy away from numbers and we start actually using variables, it is still important to recognize the factors of numbers. It'll be very helpful. So moving on, the result of multiplying two or more numbers is called their product. Another way to picture a product is by means of area. The rectangle at the right, for example, is divided into 4 rows of squares with 7 squares in each row. It contains 4 times 7 squares in all. The area of the rectangle, 28, is the product of its dimensions 4 and 7. So if we take a look at the illustration that we have here, we see 4 rows. Each row has 7 squares. If we add them all up, we would have 28. We could simply multiply and say 4 times 7. And again, if we're strong enough with our multiplication table, we would know that 4 times 7 is equal to 28. And again, you can break that down. Sometimes you need a little bit of help. Well, what if we decided to just multiply 7 by 2? Well, we know we have 4 here, so we have sort of 2 sets of 2 times 7, don't we? We have the first 2 rows of 7, then we have the next 2 rows of 7. Now we can add these all up. Now, we may remember 2 times 7 is 14. That might be a lot easier. So we have 2 times 7 is 14. Then we know that we have 2 sets of those, so it would be 14 plus 14. So again, just another way of looking at math and as addition. Sometimes we can break apart some of the more difficult multiplication and turn it into multiplication plus addition. So let's turn over to page 18. Something that helps in learning the multiplication table is the fact that if 4 times 7 is equal to 28, then it's also true that 7 times 4 is equal to 28. So that's similar to addition. The product of two or more numbers, like their sum, does not depend on either their order or the order in which they're multiplied. So let's go ahead and just write that on the board. What do we have? We had 4 times 7, and I'll just go ahead and say that's equal to 7 times 4. Okay, so, well, how do we know that? Well, what's 4 times 7? That's 28. And what's 7 times 4? Well, it's the same thing. It's 28. All right. And it doesn't matter the order. Let's say we were adding these. Okay, let's say we had 4 plus 7. Again, we're going back to addition. But just to illustrate it, we can see that we would add 4 plus 7. That would be 11. And 7 plus 4 would be 11. Okay, so we understand that when we multiply and when we add, it does not matter which order they're in. Very important to remember that because it does matter when we're subtracting, and later on we'll also find out it certainly does matter when we're dividing. Okay, now each of the number tricks that we considered in the introductory lesson included a step consisting of multiplication. For example, we were told to think of a number. And what was that number? Well, we illustrated it as a box. So we had a box. And then we were told to multiply it by 4. So we would then have one box would turn into 4 boxes, right? If we use a letter such as x to represent the number thought of, the number that we had thought of, we might write, well, what would that be? We can say this is equal to 4 with a big X times, and then there's the little x. Now we're going to discuss this because we're going to have problems using this big X as multiplication, okay? Because the symbol for multiplication used in arithmetic looks so much like the letter X, however, it is not ordinarily used in algebra. Instead, we simply write this as, and we're not going to use that anymore, we're just going to say 4, well, let's see, that didn't help out. Let's try this one more time. 4x. Okay, so we have the number 4 times x. All right, and we can't indicate this if we were using numbers such as 3 and 5. We couldn't write just 3 and 5. Let's put that over here on the side. If I said 3, 5, you would think of 35. How would you be able to tell if I'm multiplying? No, you really wouldn't be able to. So we're not allowed to do what we did over here with just numbers. But we do have a way of representing 3 times 5. Okay, so let me just put 3 times 5. There was a multiplication. We could say 3 within parentheses times 5 within parentheses. Parentheses denotes multiplication in algebra. So you remember that, okay? Actually, for the rest of your math lives, you'll need to be using parentheses for bigger problems, so you can use it. But if we're just multiplying 3 times 5, do I need to write 4 parentheses? In other words, an opening and closing and an opening and a closing. Why don't we just use the dot, the little dot, 3 times 5. We can use that. And the dot in the center, not 3.5, okay? Don't write this as 3 with a dot down here because we know that that's a decimal, okay? So we need to make sure that the dot is in the middle. And when I see 3 times 5 in that manner, what you're basically saying is 3 times 5, which again would be 15. Okay, so in this lesson we have observed that the product of two numbers such as 4x can be interpreted either as the repeated addition x plus x plus x plus x, or as the area of a rectangle whose dimensions are 4 and x. Okay, so we see the rectangle here. We have 4 on the left side. We have x at the top. We multiply them together and they are 4x. You could say 4 times x, but you can just go ahead and say 4x. We understand that when you say 4x, you're saying 4 times x. So in the next lesson, we'll see how these ideas can be applied to division.